All right, guys, here's the practice problems. We're going to do 1, 2, and 3 in lesson 2. I believe this is on page 14 of your workbook in unit 8. Okay, remember, as we said in the last video, there's 3 ways that we can write probabilities. There's the fraction way, 1/2. There's a decimal, 0.5, or there is a percentage, 50%. Okay, and in some of these problems, you'll notice that they give the probabilities in different forms. And you guys know, from working with fractions and decimals and percentages before in previous grades, that it's usually easiest if you have them all in the same form when you compare them. Okay, so let's take a look at this first one. I think you'll know what I mean. The likelihood that Han makes a free throw in a basketball game is 60%. The likelihood that he makes a 3-point shot is 0.345. Which event is more likely, Han making a free throw or making a 3-point shot? So you can see here that these probabilities or likelihoods are written in different forms. One's written as a percentage. So free throw is 60%, and a 3-point shot is 0.345. And they're written in different forms. So it's probably best to get them in the same form. So percentages is usually the easier way to look at things. I mean, like the example I used in the last video, when you watch the weather, usually they'll use percentages because they just make sense, right? It's something out of 100%. It just makes sense to us. We're used to using those. So if you guys remember how to convert a decimal to a percent, we just multiply by 100. So this would give us 34.5%. And we can see, obviously, that making a free throw is above 50%. 3-point shot is below 50%. So we can see for sure that a free throw is definitely more likely to happen in this case. All right, number 2. Different events have the following likelihoods. Sort them from least to greatest. So the smallest to the largest when it comes to likelihood or the probability of it happening. So again, probably easiest to try to get these all in the same type of form. I'll go with percentages again to compare. An 8 out of 10, think about it, if you get an 8 out of 10 on a quiz, that's an 80%. 0.37, remember we said we can just multiply that by 100. So that would be 37%. 20%, okay. And 5 out of 6. All right, so this one might take a little bit longer to do. If you guys remember how we convert these into decimals, and you're more than welcome to use a calculator. You could use it on the calculator on your computer too, if you have it, or your smartphone. Remember, if we divide the numerator by the denominator, that's going to give us the decimal form. And in this case, the decimal would be 0.83, 5 divided by 6. And 0.83 converts into a percentage by just multiplying by 100. So that would be an 83% chance. Okay, so basically now we just have to order them least to greatest. So 20%. Check. Our next one would be 37%, which I'm going to write it as its original form. 0.37. Check. 60%. Check. 80%, which was 8 out of 10. Check. And 83%, which was 5 out of 6. All right, so there's least to greatest. Cool. 3. There are 25 prime numbers between 1 and 100. If you wanted a little extra work to do, you can figure out those prime numbers and send them to me. But you don't have to do that for this question if you don't want to. There are 46 prime numbers between 1 and 200. Which situation is more likely? Explain your reasoning. A computer produces a random number between 1 and 100, that's prime. And a computer produces a random number between 1 and 200, that's prime. Okay, well, let's take a look. What's the chances that we're going to produce a random number between 1 and 100? Well, they told us there's 25, so the chance would be there's 25 chances out of 100 numbers, correct? So what we could say, what percentage would that be? That would be 25%. So there's a 25% chance that we're going to randomly generate a prime number between 1 and 100. And then 1 and 200, there's 46 possibilities out of 200 numbers. So what would that be as a percentage? Well, we could do 46 divided by 200, right? Just like in the last problem, numerator divided by denominator. That would give us, it would be 23 out of 100, or 0.23. If you notice, 46 cut in half, 200 cut in half, just an equivalent fraction. That's the way you could do it, or you could use a calculator. So this would be a 23% chance. So we have a little bit better of a chance to produce a random number between 1 and 100 that's prime, because there's 25% in the first situation, and there's only a 23% chance in the second situation. Okay, thanks guys.